So far we have displayed data as averages and counts. Now let's look at some other statistical parameters that we will illustrate as graphics. We have not yet shown anything about variance, and I think the first thing that one should look into beyond averages is to look at variance, or how the data are distributed. And a good way of looking at the distribution of data, especially if it were to be a continuous variable, is to look at histograms. And if you are interested in displaying something more than the average, maybe the median and the quartiles, then perhaps box plots should be our choice. Using the teaching evaluation data, we have plotted a histogram of teaching evaluation scores. You could see that the mean score is around 4, but then you could see very low teaching evaluation scores, not many frequently, but most frequently it's around the average, and then you see that some have lower teaching evaluation scores and some have fairly high teaching evaluation scores. The histogram approximates the normal distribution curve. Essentially you have 3.99 or 4 as the mean, the standard deviation of 0.55, looking at 463 records. This gives you a good idea of how your data are distributed. You can in fact plot multiple histograms such that you can see the difference between the subgroups. So here you have the histograms overlaid for males and females. These frequent lower teaching evaluations for females is likely to influence the average teaching evaluation score for females versus the males.
A box plot essentially looks like this. The thick line in the box represents the median. The top part of the box is the third quartile. The bottom part of the box is the first quartile. The line at the bottom is the minimum value, and the line at the top is the maximum value. And the range between the first quartile and the third quartile is called the interquartile range. In this graphic, we have created the box plots for the age variable. We can see that the median age of males is higher than the median age of females. Also, the maximum age of the males is higher than the maximum age of females. To do this in Python, we use the box plot function in the Seaborn library. We will put the gender on the y-axis and the age of the instructor on the x-axis. You can play around with the x and y-axis. If you wanted a horizontal style box plot for readability, I like to use vertical box plots. We can also add another dimension. Here we will add tenure, so those who are tenured are plotted on the right, and those who are not tenured are plotted on the left. And the blue color represents the female instructors, and the orange color represents the male instructors. We can see the differences between male and female. Instructors, male tenured instructors, are older than male untenured instructors, whereas female tenured instructors are younger than female untenured instructors. To do this in Python, add the hue argument to the box plot function. A pie chart is another way of looking at your data. You can see here in this graphic that the number of courses taught by male instructors is larger than the number of courses taught by female instructors. To do this in Python, we will use the matplotlib library. First, we specify the labels. Get the number of courses taught both by male and females, and assign it to a sizes variable. Create a subplot, insert the sizes, labels, and percentage to one decimal place in the pie function, and print out the pie chart with the show function.